Astronomers just found something extraordinary hiding in plain sight. There's an object out there in the cold, distant reaches of the solar system that appears large enough to qualify as a dwarf planet. Scientists discovered it by combing through old telescope images from 2011 to 2018. What makes this discovery so remarkable isn't just the object itself. It's where the object is located, in a region astronomers thought was essentially empty. This changes everything about how scientists understand the outer solar system, because if one massive object is hiding out there, there could be hundreds more waiting to be found. So where exactly was this object hiding all this time? The object, officially named 2017 OF201, is currently located about 90 astronomical units from the Sun. For reference, Earth sits at 1 astronomical unit from the Sun. Pluto orbits at roughly 40 astronomical units. This new object is more than twice as far away as Pluto right now. But that's just its current position. Its orbit tells a far more extreme story. The object travels on a massively elongated path that takes it as close as 45 astronomical units to the Sun and as far out as 1,610 astronomical units. At its most distant point, 2017 OF201 reaches into the inner Oort cloud, the mysterious region at the very edge of the solar system. This is a place where comets are born, and this orbit takes about 24,000 years to complete just one trip around the Sun. Scientists thought this region was mostly space. The discovery of 2017 OF201 suggests they were wrong. What separates a dwarf planet from just another rock floating through space? The International Astronomical Union set specific criteria in 2006. An object qualifies as a dwarf planet if it meets 4 requirements. First, it must orbit the Sun. Second, it must have enough mass for its own gravity to pull it into a nearly round shape, a state called hydrostatic equilibrium. Third, it cannot have cleared other objects out of its orbital neighborhood. Fourth, it cannot be a moon orbiting another planet. That second criterion is the key. When an object reaches a certain size, its gravity becomes strong enough to overcome the mechanical strength of rock and ice. The object collapses into a sphere. For icy bodies in the outer solar system, scientists estimate this happens somewhere around 400 to 600 kilometers in diameter. Objects smaller than that stay irregular and lumpy. Objects larger than that become round. This distinction matters because roundness indicates an object has undergone fundamental geological processes. It's not just a pile of rubble held together loosely. It's a world shaped by its own gravity. What evidence suggests 2017 OF201 is actually a dwarf planet? The discovery team estimated the object's diameter at approximately 700 kilometers. That's roughly 435 miles across. To put that in perspective, it's about 3 times smaller than Pluto, but significantly larger than the threshold for hydrostatic equilibrium. The estimate is derived from measuring the object's brightness and assuming a typical reflectivity for icy bodies in the outer solar system. The discovery paper uses an albedo of 0.13 in its initial calculations, although analyses with an albedo of 0.15 are also common. Depending on the actual albedo, the diameter could range anywhere from 500 to 900 kilometers. An object 700 kilometers in diameter, made of ice and rock, should be massive enough to pull itself into a spherical shape under its own gravity. Saturn's moon Mimas, which is about 400 kilometers across, is known to be round and in hydrostatic equilibrium. Astronomer Mike Brown, who discovered several dwarf planets, including Eris, has stated that any icy body larger than 600 kilometers is highly likely to be a dwarf planet. The size estimate for 2017 OF201 falls well above that threshold. But size estimates based on brightness and assumed reflectivity aren't perfect. Direct measurements would require either thermal imaging from a telescope like ALMA or waiting years for the object to pass in front of a distant star. For now, the evidence is strong but not absolute. That's why 2017 OF201 is called a dwarf planet candidate, not a confirmed dwarf planet. How do scientists even find something this far away and this faint? The discovery team, led by Sihao Shang from the Institute for Advanced Study, used a clever technique. They searched through archived images from two major telescopes, the Dark Energy Camera Legacy Survey and the Canada-France-Hawaii Telescope. These telescopes weren't looking for solar system objects when they captured the images. They were studying distant galaxies. But every image contains thousands of objects, including faint dots that might be asteroids or trans-Neptunian objects. The challenge is connecting those dots. A single bright spot in one image could be anything, but if that same spot appears in multiple images taken over months or years, and if it moves across the sky in a pattern consistent with an object orbiting the Sun, then it's probably real. Sheng developed a computational algorithm to search for exactly that pattern. The algorithm identified bright spots in the telescope database and tried to connect groups of spots that moved like a single distant object would move. This process required sorting through massive amounts of data. Ultimately, the team found 2017 OF201 in 19 separate exposures captured over 7 years from 2011 to 2018. Later, after announcing the discovery, they found additional pre-covery observations in archived images from the Sloan Digital Sky Survey dating back to 2004 and 2009, bringing the total observation baseline to 20 years. Discoveries like this are rare because objects this distant appear incredibly faint. They reflect very little sunlight and they move slowly across the sky, making them difficult to distinguish from background stars without years of observations. Why can't scientists just point a bigger telescope at 2017 OF201 and confirm its status right now? Distance is the problem. At 90 astronomical units away, 2017 OF201 is so far from the Sun that it reflects almost no light. The object appears extremely dim, even through the most powerful ground-based telescopes. Getting a clear image of its shape would require direct observation by a space telescope with infrared capabilities, like the James Webb Space Telescope. But even Webb has limited observing time, and 2017 OF201 would need to be prioritized against thousands of other targets. Additionally, confirming an object is in hydrostatic equilibrium, actually round, requires either high-resolution imaging or observation of the object passing in front of a star. These stellar occultation events are rare and unpredictable. The next opportunity for 2017 OF201 to occult a bright enough star is predicted to occur on November 27, 2029. So, astronomers wait. They gather more observations when the object is bright enough to track. They refine the orbit calculations. They study the object's surface properties using spectroscopy if possible. Each piece of data narrows down the uncertainty, but definitive confirmation that 2017 OF201 is truly round and qualifies as a dwarf planet could take years or even decades. Patience is essential in astronomy. The timescales astronomers work with don't align with human impatience. Objects like 2017 OF201 don't reveal their secrets quickly. What does one distant object tell scientists about the entire solar system? If 2017 OF201 exists, and if it's large enough to be a dwarf planet, then it raises a troubling question. Where are all the others? The object spends only about 1% of its orbital time close enough to Earth to be detectable. The other 99% of the time, it's too far away and too faint to spot. That means right now, while 2017 OF201 happens to be relatively close, there could be 100 or more similar objects scattered throughout the outer solar system, invisible because they're currently at the far ends of their orbits. Scientists estimate this hidden population could contain about 1% of Earth's total mass. That's a staggering amount of material. It changes calculations about how the solar system formed and how much matter exists beyond Neptune. The Kuiper Belt was supposed to be the frontier. The region beyond it was thought to be nearly empty until the Oort cloud began at truly extreme distances. 2017 OF201 suggests that the gap isn't empty at all. This also impacts theories about planetary migration. How did 2017 OF201 get into such an extreme orbit? The object almost certainly experienced gravitational interactions with one or more giant planets early in the solar system's history. Neptune might have scattered it outward, or it could have been kicked even further out into the Oort cloud and then pulled back inward by the gravitational influence of the Milky Way galaxy itself. Each scenario implies different things about the early chaos of the solar system. Does this discovery change the search for a hypothetical ninth planet? For years, some astronomers have argued that the orbits of certain extreme trans-Neptunian objects cluster in a specific pattern. All these distant objects seem to have their closest approach to the Sun oriented roughly in the same direction. That clustering shouldn't happen by chance. One explanation is that a massive undiscovered planet, Planet 9, exists somewhere in the outer solar system, and its gravity shepherds these objects into aligned orbits. 2017 OF201 doesn't fit that pattern. Its orbit is oriented completely differently from the other clustered objects. According to simulations run by the Discovery team, 2017 OF201 can maintain a stable orbit for billions of years in a solar system without Planet 9. But if Planet 9 exists in the same configuration some scientists have proposed, Neptune's gravity combined with Planet 9's influence would eject 2017 OF201 from the solar system entirely within just 100 million years. The object is still there. That's a problem for certain Planet 9 models. It doesn't disprove Planet 9 entirely. There are many possible configurations and orbits a hypothetical ninth planet could have, but it does add another challenge to the hypothesis. Every new extreme trans-Neptunian object that doesn't follow the expected pattern weakens the statistical case for Planet 9. The debate continues. Some astronomers remain convinced Planet 9 exists. Others think the orbital clustering is an artifact of observational bias. Scientists tend to find objects where they're looking, and they've been looking in specific regions. 2017 OF201 offers new data for both sides to consider. The solar system is still being mapped. Even 90 astronomical units from the Sun, even in regions thought to be mostly empty, new worlds are waiting to be found. Discoveries like 2017 OF201 prove that humanity's understanding of the solar system is far from complete. Hundreds of objects might be out there, invisible for now, slowly orbiting in the dark. And eventually, one by one, they'll come close enough to be seen.